Let's continue on page 33. Page 33 is about how we can take these big orbital notation diagrams and shorten them. Turns out there's a shortcut, but I taught you the long way first because somehow giving you a shortcut makes you hate me less than if I keep making it longer and longer. Probably. We'll see. I mean, you don't even know me yet, so you might hate me anyway. That's fine. Orbital notation can take too long to write, so sometimes we shorten it using a second method called electron configuration. Instead of using the lines and arrows, we replace them with just an exponent, where you write the energy level number in orbital letter just like you would in the orbital notation diagram. But instead of drawing the arrows, you just write the total number of arrows as a numerical exponent. So if you add up all the exponents, that tells you the total number of electrons, which can tell you what element it is. So for instance, with this nitrogen here, there's a 1s and a 2s. So we have 1s and 2s written down. The 1s has 2 electrons in it. There's an up arrow and a down arrow, so we wrote a 2 as an exponent. The 2s has 2 electrons in it, an up arrow and a down arrow, so we wrote a 2 as an exponent. Then we also have 2p here, so we wrote 2p here, and there were 1, 2, 3 electrons in it, so we wrote a 3 as an exponent. And then I'll point out, if you add up the 2, 2, and 3, 2 plus 2 plus 3 is 7. If you look at your periodic table, 7 electrons is nitrogen. Similarly for oxygen, there's 1s, so we write 1s. It has 2 electrons in it, 1, 2, so we wrote a 2. 2s, so we wrote 2s. It has 2 electrons in it, so we wrote an exponent 2. 2p, so we wrote 2p. There are 1, 2, 3, 4 electrons in it, so we wrote an exponent 4. We're just taking this diagram and shortening it, just writing what we see. So 1s2, 2s2, 2p4, or in the case of nitrogen, 1s2, 2s2, 2p3. These things, here and here, those are the electron configurations. That and that. And again, just like with the nitrogen, for oxygen we can add up 2 plus 2 plus 4 is 8 electrons. That is oxygen on the periodic table. Oxygen has an atomic number 8. That means 8 protons and 8 electrons. So what I want to do is I want to look at, going back to page 35, we're going to try writing the electron configuration for these 3 elements that we did orbital notation together for. So boron. The electron configuration, again, we write what we see. I see 1s, so I'm going to write 1s. It has 1, 2 electrons in it, so I'm going to write an exponent 2. I see 2s, so I'm going to write 2s. It has 1, 2 electrons in it, so I'm going to write a 2. I see 2p, so I'm going to write 2p. There's only 1 electron in there, so I'm going to write a 1, like an exponent. When you say this out loud, you say 1s2, 2s2, 2p1. This is not like 1s squared, 2s squared, 2p to the first power. You don't say it like that. You just say the number. 1s2, 2s2, 2p1. Let's try neon. Again, we're just going to write what we see. I see 1s, I'm going to write 1s. There are 1, 2 electrons, I'm going to write a 2. I see 2s, I'm going to write 2s. There are 1, 2 electrons, I'm going to write a 2. I see 2p, I'm going to write 2p. There are 1, 2, 3, 4, 5, 6 electrons, so I'm going to write a 6. And again, when you're done, if you look at those exponents, they should add up to your number of electrons. 2 plus 2 is 4, plus 6 is 10. Neon has 10 electrons. That tells me I probably did this correctly if it adds up to the right number of electrons. Let's try it for iron. Iron was a little more complex. I see 1s, so I'm going to write 1s. There are 2 electrons, so I'm going to write a 2. I see 2s, so I'm going to write 2s. There are 1, 2 electrons, so I'm going to write a 2, like an exponent. I see 2p, so I'm going to write 2p. There are 1, 2, 3, 4, 5, 6 electrons, so I'm going to write a 6, like an exponent. I see 3s, so I'm going to write 3s. There are 1, 2 electrons, so I'm going to write a 2, like an exponent. I see 3p, so I'm going to write 3p. There are 1, 2, 3, 4, 5, 6 electrons, so I'm going to write a 6, like an exponent. I see 4s, so I'm going to write 4s. There are 1, 2 electrons, so I'm going to write a 2, like an exponent. I see 3d, so I write 3d. There are 1, 2, 3, 4, 5, 6 electrons, so I'm going to write a 6, like an exponent. And again, if you add all these up, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 6 is 26. Oh, we get the same number of electrons as what iron was supposed to have. So that's a clue we probably did it correctly. Okay, at this time, you should go back through this page 34 and 35 and do the electron configurations for all the elements that you've already done orbital notation for. So go back through and do electron configuration, electron configuration, electron configuration, all the way down on both pages. Still leave NGC blank. I'm going to do that in another video. But go through and try all your electron configurations, and you can check them with Miss Woodlock when you're done.